Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video, we'll look at a final topic in gradients, which is how to handle gradient values that come up as none. And specifically, we'll look at these cases where we would get gradient values calculated as none. And it's good to be aware of these cases because when writing the code, it's sometimes can happen that uh, gradients are none and you're trying to figure out why that is happening. So knowing this ahead of time could help kind of get the code working and maybe resolve the errors. Now let's look at the very first case of a gradient that comes up as none. We'll create a new heading here, and this is the gradient of none, and the case here is that the target is not connected to the source. So target, give it font size, target not connected with the source. And for this, we'll create two variables. So x is equal to tf dot variable 1.0, and then we'll create y is equal to tf dot variable, this is let's say 2.0, and then as usual we will record it on the tape. Record, so with tf dot gradient tape, a gradient tape as tape, and then we calculate value of y, which is equal to square of calculate value of z, which is square of y. And note here, point to note is that x that we created above is not connected with z, only y is connected. So now when we try to calculate the gradient, grad of z with respect to x, tape gradient z with respect to x, what we would expect is that it will come up as null. Grad z with respect to x, when we run this, we get the value of gradient as none, and that's because we never used the variable x that we created here. Therefore, we are getting value of none. The next case is to get another case. Replaced variable with a tensor. And for this, we'll create a variable first. So let's create a variable x is equal to tf dot variable, and let's give it a value 2.0. And then what we'll do is we'll perform the recording and calculation of gradient within a for loop. So let's create the for loop for epoch in range 2. So here what we'll do is we'll first do record, and then we'll do calculate the gradient, and then we'll do update the input variable. So for the recording, you already know the step with tf dot gradient tape, and here as tape, here we can specify y is equal to x plus 1, so that's the operation. And then for calculating the gradient, we have grad underscore y underscore x is equal to tape dot gradient, and then here we can specify y and x. So now if we print gradient, of y with respect to x, then we can type grad underscore y underscore x. Now what will happen here is that once we update x, so if we say x is equal to x plus 1, then it changes to tensor. So here if I type so variable, updating a variable changes, can change it to tensor, can change it to a tensor. So in this case it would. So additional point we can type is print, will print the epoch. So n epoch, and the reason for this is we will be able to see in which iteration the x changes from variable to a tensor, and therefore the gradient comes up as none. Type x, and here we have this, then type of x. Okay, so with this we now run this, and as you can see in the first iteration the type of x is a variable, resource variable as it says here, and therefore we do get a value of gradient calculated in the output, grad y with y underscore x, which is 1. However, in the second iteration, so after this value is calculated, we are updating x, and what that does is it changes it to a tensor, eager tensor, and therefore because tensor is not trainable, therefore we get a value of none here. However, if we watch x, tape.watch x, and then run this, now we do get the value for the gradient after the variable x is updated by 1, and it becomes a tensor, but because we have it on a watch we get the gradient calculated. Now let's look at another example. So I'm going to create another cell here, and this deals with did calculations outside of TensorFlow, and this is very easy to miss while writing the code. So variable will create a variable x, x is equal to tf dot variable, and then here you can type 1 point this and 2 point, that's the first row, and then we have the second row where we can have 3 and 4. So that's our variable, and the next thing we do is record. So with tf dot gradient tape as tape, and then the first operation that we are going to do here is x2 is equal to x, and then we have square of x. So that's within TensorFlow. The next one is we'll do outside of TensorFlow. And this is we are doing it in NumPy. And what we are doing is we calculate y is equal to np.mean. We are using NumPy function. x2 axis is equal to 0, and then we come back into so we come back inside of TensorFlow, and we can then calculate y again is equal to tf dot reduce mean y, and we have axis is equal to 0. So with that, then we are now ready to calculate the gradient. Grad underscore y underscore x is equal to tape dot gradient y comma x. Then we can print it, print grad underscore y underscore x, and we have the same thing here, grad underscore y underscore x, and when we run this we see that the output gradient for y with respect to x is none, and probably wondering why that's happening. We have variable y, which is trainable. We have it connected to x2, then we have x2 connected to y, and again we have y connected with y. So everything is checking out, but then why is this coming up as none? And the reason is this step. Here we went outside of TensorFlow, and what that broke the continuity, and therefore we are getting value of the gradient as none. Had we changed this to within TensorFlow, for example, if we do tf.reduce underscore mean x2, and if we comment this out and now run this, now we should get a value calculated for TensorFlow. So we have an error, invalid reduction dimension. Okay, what we need to do here is provide an axis is equal to 0. Now when we run this, we get the output which is tensor, as we would expect. So that's something to keep in mind, is that the gradient, if you are getting it as none, then one of the cause could be that the calculations are going outside of TensorFlow. The next item we'll look at is gradients uh, go through a integer or string and not a float. So let's create a markdown here with a heading, and we'll call this took gradients to an integer or string. Here points to note are that the first one is that integer is not differentiable. So integer is not differentiable. And the second one is, of course, string is not differentiable. And point to note, another one is here that TensorFlow, it does not automatically cast between types. And with this, then now let's look at an example. Tensor x, and we'll create tf.constant, and we'll give it a value 2 and not 2.0. And note that this now is an integer. And we'll go ahead and create the tape by recording. Record with tf.gradient tape, and as tape we perform the operation. We can use tape.watch x, and then perform the operation y is equal to x and x square 2, and finally let's calculate the gradient from this tape gradient, and here we have grad underscore y underscore x is equal to tape dot gradient y comma x. And now when we print this output, print gradient of y with respect to x, and here we type gradient of y with respect to x. Here you'll see that here in the warning we see that the data type of the watch tensor must be floating got integer 32, because we have an integer here, and therefore it's not able to calculate the gradient, and therefore we have the gradient as none. If we change this to 2.0 and now run the exact same code, this time because it's a float, we do get the output for the gradient, which is 4. Next item we'll look at is taking through a stateful object. So let's create a heading here. Took gradients through a stateful object. And points to note here is that look at the docs tensor. So this has value, but it does not have a state. And a variable has value and it has state, but then the variable state blocks gradient calculations from going farther back. We'll see an example of this. So let's create two variables here. Variable, and let's create x0 is equal to tf dot variable, and let's give it number 3.0, and then create another one x1, and let's give it a value of 0. tf dot variable, and let's call it 0.0. Now let's go ahead and record the tape. So with tf dot gradient tape as tape, and here what we'll do first is we'll update the value of x1. So what we'll do is we'll update the value of x1. So x1 dot assign x0, and then I need to turn off this auto help, and then we need to perform an operation. So operation, which is y is equal to, so this is also operation. So here we type tape starts recording from x0, and here then we have y is equal to x1 squared, so we don't need the parenthesis there. So with this then we can now calculate the gradient. So for that we have gradient grad underscore y underscore x0 is equal to tape dot gradient y comma x0, and then we can print it. Print gradient y underscore x0, and we have gradient y underscore x0. Now when we run this, as you'll see, this has a value of 3. We have value for x1 which is 0. So when we input the value, when we assign the value of 3 from x0 to x1 and then square x1, we would have thought that the value for x1 that has changed is recorded in the tape, and then when we calculate the gradient of y with respect to x0, we should have gotten the value for the gradient out, but that did not happen. And here if we look at x1, we try to calculate the gradient for y with respect to x1, and let's print that as well. So with x1 we should see a value. We do not, because we are using the same tape, so we need to specify persistent is equal to true. And now as we can see here, with respect to x1 we do get a value because x1 is stored in the tape separately. But if we try to calculate the value of gradient with respect to x0, we do not get that. And that's because here's how I like to think about it, is that the variable x0 is stored in memory with some address. Now, when we assign the value of x0 to x1, we are assigning the values and not the address. So we are updating x1, but we are not attaching any pointers or the memory location of x1 to memory location of x0 to x1. And so x1 is not in a way attached to x0 is not attached to x1, and therefore when we are and that's what this says here, the variable state blocks, so variable state blocks the gradient from going farther back. And so we go up to x1, but we cannot go up to x0 to calculate the gradient. Now, another option around this is if we change, so instead of assigning a value from x0 to x1, if we simply uh, equate it to x1. In this case, then when we run the code, we see that it is able to the gradient tape is able to trace back to x0 to calculate the value for gradient for y with respect to x0. So that's the idea behind this. And then we have final two operations that we can look at. The first one here is create a cell, and the first one is not registered, no gradient is registered. So no gradient registered. And this is the case where if there is a function within TensorFlow that does not register a gradient, and if you use that in the gradient tape, it's not going to help in calculating the gradients. A variable img is equal to tf dot variable 0.5, 0.0, 0.0, and then we have delta is equal to tf dot variable, and this called is 0.1, and we have record. So with tf dot gradient tape as tape new underscore img is equal to tf dot image dot adjust underscore contrast img delta. So this is the method or function we are using, and point to note in here is that gradient is not implemented in the tf image dot adjust contrast. And so now when we calculate the gradient, we have gradient is equal to tape dot gradient, and we have new image, which is the contrast adjusted image, and then here within a list we specify image and delta, and then we print the value for gradient. Print gradient as here. So what we'll do is we'll add a try catch around this. So try this, and if we get an error in this, then we catch the error, try except, not try catch. So here we have lookup error as e, and here we can type print f, and within curly braces type of error dot underscore name underscore close the curly braces, colon, again open curly braces E colon, and now when we run this, we see that this is the error we get. Lookup error, gradient registry has no entry for adjust contrast. So if the methods within TensorFlow that are not implemented uh, to be recorded on a gradient tape, if those are used within this with statement, then it won't get recorded, and therefore it'll throw an error, as we can see here. And now let's look at the final item with working with gradients in TensorFlow. And this is that we have seen so far that getting none values, we have seen getting none values. However, sometimes it's helpful to get a 0 instead of none. And that's exactly what we'll try to do now. So what we'll do is we'll create a heading zeros instead of none, and this is simple case where we'll simply replace a none with a 0, and that is straightforward. So we'll create variable x is equal to tf dot variable, and here we'll assign 2.0, and we have 2.0 again, and then we have y is equal to tf dot variable, and let's give it 3.0, and then we can record. So record with tf dot gradient tape as tape z is equal to y and square, and then we have gradient, and here if we type gradient is equal to tape dot gradient and z over x, and if we try to print the gradient and run this, we'll see that it prints out a value. So there is a error there. So let's figure how I forgot the open close parenthesis. So let's do that. So here when we run this, we get a value of gradient is equal to none. Now to get a value of 0, all we need to do is in here we can add a argument unconnected gradients is equal to tf dot unconnected gradients dot 0, and now when we run this, we should get a value of 0. So here we see that we got a value of 0 in the output for the gradients instead of none. So that was it for this video and the series on gradients. I hope you are now you have plenty of information on how gradients work in TensorFlow, or how gradient tape works, and how we can calculate the recorded information from a gradient tape to get the actual gradients. We also looked at cases where gradients could come up as none and the reasons behind those. We'll continue this discussion in TensorFlow, and eventually we'll reach Keras. So stay tuned, and if you have any comments or suggestions, please let me know in the comment section below. I hope to see you all in the next video. Please like, share, and subscribe. Thank you.